Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 50, and this problem tells us that carbon-hydrogen bonds are sometimes more acidic than oxygen-hydrogen bonds. Explain why the pKa of this anhydride molecule is lower than the pKa of this alcohol molecule. So we're talking about acidity here. So the stronger acid will have the more stabilized conjugate base. So let's remove the most acidic protons in each of these molecules, this being the alpha proton in the anhydride and this being the alcohol proton in our alcohol. So if you remove these protons, you'll be left with a carbanion here and a negatively charged oxygen here. So now let's look at the stabilization effect. Well, for this one, we can have a few resonance structures. We can move these two bonds here to make a new pi bond, making a bond, you make a bond, you break a bond. Alternatively, you can go to the other side, to the other carbonyl group. So in essence, we would have 3 resonance structures. So here we have 3 resonance structures that are going to stabilize and move around this negative charge around the ring. However, this alcohol here has no resonance structures and has very minimal inductive stabilization, and it's really not stabilized. So in terms of stability of conjugate base, this conjugate base of the anhydride is far more stable than the alcohol, and the more stable the conjugate base, the better the acid it's going to be. So that explains why the pKa of this anhydride is 9 versus this alcohol, which has no stabilization effect other than putting a negative charge on an electronegative atom, has a strong or higher pKa or more basic pKa of 16.